Hey, this is Mr. Warden. I'm going to do a video on how to do some sneaky multiplication tricks using differences of squares and perfect squares right now. So here we go. I'm going to take first a group of multiplications that look kind of annoying to do, and we're going to do them out using the difference of squares structure. Now, if you recall, the difference of squares is something squared minus something else squared is going to equal, so if I say a squared minus b squared, it's going to equal a plus b times a minus b. So you'll take the square root of each of these things. A squared, the square root of that is a, and the square root of b squared is b, and you're going to get the sum of them, and you're going to get the difference of them, and you'll multiply those. So you'll multiply the sum and the difference by each other. Now we're going to take this structure, and I'm going to structure this multiplication problem using this. And by doing that, I'm going to be able to take advantage of this structure here, make my math much simpler. So 21 times 19 is the same as 20. Notice that it's 20 plus 1 times 20 minus 1. And what that means is I can say, and it's already giving us the answer, but that'll just confirm things. I can say, since this is 20 plus 1 times 20 minus 1, I can say 20 squared minus 1 squared. And that'll get me the same answer. So all I have to do is figure out what is 20 squared. 20 squared will be 400, and 1 squared will be 1. So 400 minus 1 will equal 399, and that's my answer. Okay, let's try another one. Let's try a little harder one. This one's a 3-digit one, but you might notice that these are both 3 away from 400. This one's 3 more, and this one's 3 less. So I'm going to set this up as 400 plus 3 times 400 minus 3. And now all I have to do is get the square of each of these and get their difference. So it'll be 400 squared. This is the sum of them times the difference of them. So that becomes the difference of squares. 400 squared minus 3 squared. And you see I'm getting the same answer here. I can go ahead and I'm going to go ahead and do the math myself and demonstrate that it's really true. So, and you can do this without Desmos, without a calculator, pretty quickly, because 400 squared is going to be 16 followed by 4 zeros. 1, 2, 3, 4. And then I'm going to subtract 3 squared, which will just be minus 9. And that is going to end up being, I'll just take 9 away from 160,000. I'll end up with 159,991, and that is exactly what I got here. Okay, let's do one that's a little harder. So this one, I've got 8,000 times 7,988. Well, 8,012, so 8,012 times 7,988. 8,012 is 12 more than 8,000, and 7,988 is 12 less. So I can set that up as 8,000 plus 12 times, mouse there, times 8,000 minus 12. And so I'll end up with 8,000 squared minus 12 squared. Well, 8,000 squared is going to be 64, followed by 6 zeros, so 64 million. 1, 2, 3, 4, 5, 6. 1 and 12 squared is just going to be 144. Okay, so what I'm going to have to do is I'll basically do 63,999,000, and then I'm going to take the 144 from the rest. So that'll be a 6. That'll be 9 minus 4, so that'll be a 5. And that'll be 9 minus 1, so that'll be an 8. So 856, and everything else is 63,999,856. And that's how we do it. It's not that horrible to do once you've got it set up like this. And you can do even crazier ones. Maybe I'll do one more. Let's see. I'll do 6. Here's what I'll do. I'll do 12 million. 12 million 20. Did I get the right number of places? Yes, 12,020,000 times 11,999,980. Okay, and you can see here it's giving me this number, but I'm going to go ahead and work it out. So let's see, this is 20 more than 12 million, and this is 20 less than 12 million. Okay, so here we go. We're going to have 12 million plus 20 times 12 million minus 20. And that's going to end up being 12 million squared minus 20 squared. And 20 squared, so let's work all that up. 12 million squared is going to be 144 trillion. So 144 for the 12, followed by 12 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then I'll be subtracting 20 squared, which should be 400. And so it's rounding things for me here, but I'm going to go ahead and work it out exactly. So what I'm going to end up with is a 143 followed by a whole lot of nines, and then this is going to be 600. So 143 999 999 999 600, and that's my answer. Okay, so that's differences of squares. What we now we're going to do is perfect squares. Perfect squares take a little bit more work, but let's say you wanted to square 21, okay? And of course, it gives us our answer, 441. We're going to use this structure, a plus b squared, equal a squared plus 2ab plus b squared. So the first thing I want to do is I want to set it up like this. So 21 squared could be rewritten as 20 plus 1, and then we'll square it. Okay, now since the perfect square structure goes into this form, what I now can do is I can take this 20 and this 1. I'll treat this as A and B, and I'm going to copy pasta this down here so that I have a structure to work with easily. So what's going to happen is A is going to be 20. Wherever A shows up, I'm going to replace it with 20. And, oops, there, thank you. And then wherever B shows up, I'm going to replace it with 1. So there we go. We got one more B to replace. 1 there. And so now I just have to simplify all this. So copy pasta that and put it here, and let's simplify it. All right, 20 squared, we've already done that, but that'll be 400. And then 2 times 20 times 1 is just going to be 40. And then 1 squared is just going to be 1. So I've got 400 plus 40 plus 1, which will be 441. And it confirms that that's the answer. Now, the other version of the perfect square, which is a minus b squared, the quantity a minus b squared equals a squared minus 2ab plus b squared. We're going to do the same thing here. We're going to take that structure, and I've got 19 squared, and I'm going to write 19. Notice it's 1 less than 20. I can write that as 20 minus 1 squared, and I get 361 both times. It's the same thing. I'm going to take this structure here, and I'm going to replace A with 20 and B with 1 again. So we'll be able to work the whole thing out. Replace B with 1. It's actually, yeah, we'll replace it with 1. Let's see, I'm going to replace B with 1 here. I'll replace A with 20. And I will replace A with 20. So there I've got all this, the whole gang is there. I've got all the parts. And I'll start simplifying. 1 squared is just 1. Over here, I've got 20 squared again. That's just 400. And here I'm going to be doing 2 times 20 times 1. Of course, it's negative. So that's going to be negative 40, so minus 40. So I'm going to have 400 minus 40 plus 1, and that is going to be 360 plus 1, so 361. All right, let's take a look at some of the ones below because I gave you some and made some crazier ones. Let's look at this one. So 403 squared. Well, 403 squared is the same as saying 400 plus 3 and then squaring it. So we can take the 400, we'll square that, 400 squared. Then we're going to say plus 2 times 400 times 3, because the middle part is going to be double the 40 times 3, and the 400 times 3, I mean. And then I'm going to add 3 squared to the end. Okay, and the whole thing I'm doing is exactly this structure. You know, it's either the minus or it's the plus. If this is minus, we put a minus here. If that's a plus b squared, we put a plus there. So there's the two structures. Right now I'm working with this one. So this structure here, the square of the first term, the square of the last term, and then 2 times the first and last term. Okay, so let's go back down to our calculation space. So I've got this. I'm going to copy paste this to the next one. And 400 squared is going to be 16 followed by 4 zeros. So 160,000. 160,000. Then 2 times 400 times 3. Let's just focus on the 2 times 4 times 3. That's 8 times 3 or 24, followed by 2 zeros. So that's going to be 2,400. And then 3 squared is just 9. So we'll do that. That's a 9. And so I just have to put everything together. 160,000 plus 2,400 is going to be 162,400 plus 9. Put a 9 at the end, and there we have it. And that's what it was telling us the whole time. Okay, let's try another one. Well, this one, I'm close to 400. So I'm going to pick a number that's easy to work with. I mean, I could pick 398 minus 1, or I could pick 396 plus 1 if I wanted to, but who wants to do that? So I'm going to treat this as 400 minus 3 squared. And that'll be an easy one to work with. So that's going to be 400 squared. This is minus here, so it's going to be minus 2ab. So minus 2 times 400 times 3. Oops, I did some weird stuff there, didn't I? Let me fix that. Okay. This is 400 squared minus 2 times 400, which is the A, times 3, which is the B. And then I'm going to add 3 squared at the end. Okay, and notice I keep getting the same thing for each of these. So let's work it all out. So 400 squared, well, you already worked out that is 160,000. And then I'm going to subtract this time instead of adding. So I'm subtracting 2 times 4 times 3, slap a couple zeros on it because that's 100. So 2 times 400 will be 800, times 3 will be 2,400. So minus 2,400. And then I will add 3 squared, which is 9. Move that out of the way. Now this one takes a little more effort, so I'm going to go ahead and get my pen. I've got 1, 6, 0, 0, 0, 0. Okay, and I'm going to take away 2,400. And at the end, I'll add 9. So I'm going to start off just dealing with that part. Okay, so that'll be 0 and 0. And then I'm going to have to borrow from the 6, so that's a 5. And that'll be a 9, but that'll be a 10, but I'll need it to become a 9, so that'll be a 9. And that will be a 10. Okay, so 10 minus 4 will be 6. And then 9 minus 2 will be 7. And then that's 1, 5. And then we've got to add the 9 at the end, so plus 9. And so I end up with 157,000. What am I saying? Put that there. 157,609. Put a little comma there. Okay, now let's keep going. So that's how you do that one. Let's do one that's really a bit gnarly. So we got 8,012 squared. So I'm going to treat that as 8,000 plus 12 because 8,000 will be easier to work with. 8,000 plus 12 squared. And since the perfect square structure is just going to be a squared plus 2ab plus b squared, 8,000 is a, 12 is b. So I'm just going to write that structure down here just one more time to remind you. Plus or minus 2ab plus b squared. That's my structure. So I'm just going to start replacing letters. So a, wherever a shows up, is going to be 8,000. And wherever b is, I'm going to replace that with 12. So times 12. That'll be 12 squared. Okay, so I'm going to get ultimately 64,192,144. Let's see if I can make that work with the calculations. So 8,000 squared is going to be a 64 followed by 6 zeros. 6, 4, 1, 2, 3, 4, 5, 6. Now, 2 times 8 is 16 times 12. Let's see. 8 times 12 is 96. So if I doubled 96, I would get 182. So that should be, I'm sorry, 90, I'm sorry, 192. Okay, nearly did a jumbo mistake. So I'm going to end up with 2. 2 times 96 will be 192. Slap 3 zeros on it on account of this actually being 8,000. So I get plus 192,000. And then I'm going to add 144. Okay, so let me erase all this stuff over here and give myself some room to work with. So I'm going to lay it all out up here. Okay. Here we go. Let's use blue this time. So I've got 64 million 000. I really do need to come up with a better mouse writing tool. 64 million plus 192,000. So 1. This will not be hard to add. Could have done this with mental math, of course, but I want to show you it working in the world. So there we go, 144. So this is going to give me the square of 8,012. All right, so bring it all down. So that's just going to be 144 here because it's all plus 0. And then this is all plus 0 as well, so it's going to be 192. Ooh, there's lightning happening and thunder happening behind me while I make this video. And 64 here. So I've got 64,192,144 is the square of 8,012. And it agrees with Desmos, and I hope that was helpful to you. In general, what you're going to want to do is you're going to take a look at a number, and you're going to think, okay, how can I break that number down into 2 parts, maybe a sum or a difference, and have those 2 parts be numbers that are reasonably easy to work with? Okay, so if I gave you, so that's for the perfect square. So if I'm squaring numbers, so if I gave you 79 squared, you could either set that up, you decide to, you could say 70 plus 9 squared and go through the process using the perfect square structure, or you could say 80 minus 1 and square that. Either way is going to work. If I gave you something like 56 times 64, You might notice that those are both 4 away from 60, and now we're dealing with a difference of squares structure. So we can say 60 minus 4 for 56, and then 60 plus 4 for 64. And that'll all end up just being the difference of square structure. So 60 squared minus 4 squared. So just to recap, we're just applying those structures of the perfect square and the difference of squares to solve complex or more challenging math problems in a way that's not the traditional algorithm. I hope that was helpful.